Okay, ladies and gentlemen, so we're going to look at finding the x and the y-intercepts algebraically. So in looking at the x-intercepts, or on the x-axis, this is actually the horizontal axis when y equals 0. So what we're going to do is plug in y equals 0 into the function. And the y-intercept will occur, again, looking at the y-intercept, that's actually the vertical line, x equals 0. So what you're going to do is plug in x equals 0. So what we're going to do now is look at a function for the graph below. So if we look at the roots, we have x equals negative 2.5, x equals 3.2, and x equals 7.5. So what we're going to do is see, well, what function may have made that. So if I look over here, we have x plus 2.5 would be the factor that would have made this equation. Similarly, over here, we can subtract over the 3.2 and say x minus 3.2 equals 0. And then over here, same thing. We can subtract over the 7.5 and set those equal to 0. And then we can multiply all three things together to make our function. However, we might have a vertical stretch or shrink. So what I'm going to do is write down y equals a times x plus 2.5 times x minus 3.2 times x minus 7.5. And then I'm going to actually pick this point, 0 to 40, which tells me x equals 0 and y equals 240. So I'm going to plug those into the function and get 240 equals a times, if I do 0 plus 2.5, that's just going to give me 2.5. Similarly, plugging in 0 here gives me negative 3.2. And then over here, I get negative 7.5. So now what I'm going to do is multiply 2.5 and negative 3.2 and negative 7.5. And I got 60. So we would have 240 equals, I'm going to bring the coefficient to the front, so it would be 60a. And then in solving this multiplication equation, 60 times a, I'm going to divide both sides by 60. And I get a is equal to 4. So in writing the function, we would have y is equal to, plugging in 4 for a, and then writing my x plus 2.5 times x minus 3.2 times x minus 7.5. In looking at this in factored form, I'm going to multiply 3 x's. So that means I'm going to end up with x to the third power. So my degree is 3. In looking at the graph, the domain, the x numbers are going to go on forever. So it goes from negative infinity. And then in the positive direction, they're going to increase forever to infinity. Or we could also say that's all real numbers. Similarly, for the range, the lowest number on the y-axis is negative infinity. And on the or on the y-axis, as we increase, is positive infinity. Or we could also say all real numbers. And then my end behavior, if I look here, as x decreases, y decreases. And then here, as x increases, y also increases. And then multiplicities refer to a repeated root, and none of these factors are repeated, so we have none. So now, go ahead and practice this problem. And then if you look on the rest of the worksheet, there is just more problems for you to practice. And then we'll correct those in class. I do want to talk about some sketches here for you. So it says sketch a graph for each situation if possible. If it's not possible, write not possible. So a quadratic function with only one real zero. Well, that means the quadratic touches the x-axis once. So I'm going to just sketch my graph here. And then here's the x-axis, here's the y-axis. So to touch it once, I'm just going to draw one over here and have that vertex touch the x-axis only once. If it has no real zeros, it's just a quadratic function that doesn't touch the x-axis. So we can look and see that. If we have a quadratic function with 3 real zeros, there's no way a parabola can touch this x-axis 3 times. So this one is not possible. And then let's look at the graph of a cubic function. So we have to draw a cubic function with 1 real zero. So I'm going to type in y equals x to the 3rd power, and then graph. And we can see here, this actually is a cubic function with 1 real zero. So I can draw that one. And then for a cubic function to have 2 real zeros, sorry, that line's a little crooked. Oops, and that one actually has 3. My fault. So to make that have 2, I could actually just slide that graph down and make this spot touch just once and lower it. So in looking at that, I could draw like that. So again, here's the x-axis, here's the y-axis. Let me clean that up and draw my arrows on the graph. And then I can cross that out. That didn't work, but I learned from my mistake. And here's 2 real zeros. And then I look at a cubic function with no real zeros. Well, this is decreasing for my end behavior. And then my long run behavior, it's increasing. And if I flip that over and reflected that over the x-axis, that also is going to go and increase for the end behavior. So as x decreases, y increases, and as x increases, y decreases. So this is not possible.